Ellie and I will explain you our abstract. In this project, we will explain what are the four conic sections: ellipse, circle, parabola, and hyperbola, including how we can get them, the formulas of each one, all their features, how we can identify them, etc. The conic sections surround us in our daily life, but we don't realize it because we don't know them very well. But one of the purposes of this project is to help society to identify them in our real lives, and not only in the planes.
Well, in the example that we did, we make a conic section in wax paper. The idea was to make, to involve the wax paper in a more creative and innovative way. Some keywords that you're going to find in the video are right circular cone, menacunes, foci, intersections, directrix, planes, center, radius, axis, fixed points, and distance.
Objectives. Our general objective is to make a complete description of the origin and formation of each of the conic figures, which include ellipse, circle, parabola, and hyperbola, and also make a description of their distinct application of these figures.
The specific objective is to describe the different types of conic figures, to understand the purpose of each figure, and acknowledge the elements and features of each of the conic figures.
As conic sections are particular shapes formed by intersection of a plane with a cone, and depending on the angle between both terms, we can only obtain four different conic sections: circles, ellipses, hyperbolas, and parabolas. As an alternative, by manipulating a piece of paper and making determined folds, the exercise of folding paper can be used for pedagogical purposes. To study and illustrate elementary planes, the key lies in geometrically interpreting what is being done when the paper is folded. There can be visualized precise geometric concepts. Conic sections are used in many fields of study, particularly to describe shapes. Two massive objects in space that interact according to Newton's law of universal gravitation can move in orbits that are in the shape of conic sections. They could follow ellipses, parabolas, or hyperbolas, depending on their properties. With ellipse, one of them shows the constancy in the distance from any point to the focus on the other point, and all of them explore the relationship between all the crucial slides that the ellipse have and could have.
The applications of the conic sections. The conic sections are not used only in math, but can also be applied in many other fields of study, particularly to describe the shapes. Two massive objects in space that interact according to Newton's law of universal gravitation can move in orbits that are in the shape of the conic sections. For example, they could follow the shape of ellipses, parabolas, or hyperbolas, depending on their properties, as said by Candela 2019. As stated by Candela in 2019, with ellipse, one of them shows the constancy in the distance from any point to the focus on the other point, so it becomes a focus. And all of them explore the relationship between all the crucial slides that the clips have and could have. Page 7, Candela 2019.
Hi, my name is Luis David, and I'm going to explain two conic sections that are the circle and the ellipse. A circle is a collection of points formed when its intersection with the cone arises from a common center point, and as long as the plane is parallel to the base of the cone. All circles have certain features: a center point, a radius, which is the distance from any point on the circle to the center point. Circles have an eccentricity of 0. Formulas. On a coordinate plane, the general form of the equation of the circle is x squared plus y squared plus ax plus by plus c. It's equal to 0. And the standard equation form is x minus h squared plus y minus k squared. It's equal to r squared, where h, k are the coordinates of the center of the circle and r is the radius. In the case of an ellipse, it is formed when the sum of all set points distances from two fixed points, foci and directrices, is constant. Ellipses have these features: a major axis, which is longest width across the ellipse, a minor axis, which is the shortest width across the ellipse, a center, which is the intersection of two axes, two focal points for any point of the ellipse. The sum of the distances to both focal points is a constant, and the formulas of the ellipse are: the standard equation center at the origin is x minus h squared divided by x squared plus minus k squared divided by 2 squared minus 1, or x minus h squared divided by b squared plus y minus k squared divided by a squared. And the general equation for an ellipse is x squared plus y squared plus ax plus by plus f, and it's equal to 0. Thank you.
The general idea of the workshop and this project is to help people understand how conic sections work and how can they be formed in wax paper, making it by ourselves. Also, showing them the process step by step so they can find an easier way to learn and understand the topic.
The purpose of this workshop is to identify conic sections outside the planes, but also in real world, because in reality, conic sections that are circle, ellipse, hyperbola, and parabola surround us in our daily life, only that we don't realize it because it is already normal for our view. The materials for this experiment are wax paper, ruler, pen or pencil, and a geometric compass.
The procedure. Well, first of all, we have the materials. We need a wax paper, a ruler, a pen or pencil, geometric compass. The procedure. The first step we have to do is draw a circle in the center of the wax paper. The second step is with a ruler to make a 15 centimeters mark from the center of the circle. Next of that, the third step we have to do is draw a line from the mark of the vertex to a circle, and then fold the wax paper following the ones that are already marked. With these 3 steps, we have to repeat them 16 times and fold it 16 times, according to the lines we already make. And that will give us conic sections in a wax paper, as you can see in the video.